Okay, so this is week 8 for the live session, and I'm Jyoti Sharma, and this is my brief introduction. I'm a PhD student right now in ISL Bhopal. Uh, I had my MSc in Forest Research Institute in Environment Management and BSc Honors from University of Delhi. And because I'm the PMRF Research Fellow, that's why I have the responsibility to teach you people live to just get the R credit. So, so how we will proceed? This is obviously that we have a lot of MCQ question, and with the discussion, we will try to solve it. And your participation is highly valued. And in this week 8, we will try to cover one basic study about the indoor air quality. Uh, we will not cover that much for this case study because we already have talked much about this. Then we will discuss about regional and global environmental issues, and we have three major issues. The one is ozone layer depression, the second is global warming, and third is acid rain. And out of which two part, that is uh, global warming is just the part of the climate change, so that's why I told you that we will discuss three topics today. Initially I have MCQs related to the previous assignment, as we will solve it, and then we will move to some another MCQs that I have created for you. So this is the first question. This is from the previous year assignment question, and this is in the case study entitled Indoor Air Quality in Nursery Building. Which of the following method was not included in the method in the study for improvement of indoor air quality? And I have option: the installation of an air purifier. The second is change of building material. Third is installation of new ventilation, and third is ultraviolet germicidal irradiation. So what do you think? What should be the answer? Rashmi gave me answer D. Okay. Yes, answer should be D because uh, the sir already talked about how we can manage air quality, indoor air quality in nursery building, and we had three methods by which we can control. The first is installation of air purifier. The second was we can change the building material. For example, like wooden material, we can buy a good wooden material so that the use of formaldehyde can be avoided. Then the installation of the new ventilation so that air can pass, outside air can come, enter, and that's why it can a little bit dilute the polluted air that is inside your nursery building. Okay, so we talked about this three method, but this one UVGI was not among that method, so obviously D will be the right answer. Then we have ozone, that is tropospheric, or we can say it is the ground level, and it is not emitted directly into the air, but it is created by which reaction of its precursor in the presence of sunlight? So I have four options: hydrolysis, combustion, photochemical, and the convection. Nishant already gave me answer C for that. Rashmi also gave me C. Alka, what do you think about this answer? Okay, you people gave me answer C, and of course the answer is C because uh, this ozone is formed when we do have the sunlight. We have some precursors such as nitrogen dioxide and the volatile organic compound. So volatile organic compound, uh, this nitrogen dioxide in the presence of sunlight can lead to the formation of the photochemical smoke, and one of the main product of this photochemical smoke is nothing but the ozone. So yes, photochemical means, photo means in the presence of light, and chemical is chemical reaction, so there will be chemical reaction in the presence of sunlight. So yes, C should be the right answer. Then which of the following international treaties significantly decreased the ozone depleting substances and was effective in healing the damaged ozone layer. So you have to tell me the treaty. And we have four type of this. The first is Montreal Protocol, Paris Agreement, Kyoto Protocol, and the Helsinki Protocol. Alka already gave me some answer. She gave me A. We will talk about this as well. Rashmi gave me B and can you mute yourself, Nishant? Okay. Yes, there was some kind of noise. I don't think that you were speaking. It was kind of noise. That's why I told you to mute yourself. If you want to, what? What, Nishant? Okay, so we will talk about it as well at length. What do you mean by this Montreal Protocol? What do you mean by Paris Agreement, Kyoto, and the Helsinki? Okay, Nishant. So it was Montreal Protocol. The Paris Agreement was related to just retain the temperature up to like we don't want to increase our temperature by 1.5 degrees Celsius. So this was signed under this Paris Agreement. But if we talk about the ozone depleting substances, then it was the Montreal Protocol where we decided that we have to remove substances that are leading to the depletion of the ozone. We will talk about it as well. So answer should be A, that is the Montreal Protocol. Kyoto Protocol is another that was related to the reduce of greenhouse gases, and we will talk about it as well. Helsinki Protocol was nothing. I just added it. So the answer should be the Montreal Protocol. Okay, which of the following greenhouse gas is the most important long-lived forcing of climate change? So I have four options: the methane, nitrous oxide, carbon dioxide, and the ozone. Okay, Rashmi gave me answer C. So in this question, we have to keep in mind that we are asking for the gas that have the long lifetime. So what's the life? You must know what should be the life. What is the lifetime of methane? What is the lifetime of nitrous oxide, carbon dioxide, or the ozone? And the second thing, we also should know which of these are the greenhouse gases. So if you know these two questions, then obviously you can give me the answer for this. And Rashmi gave me right answer. That is the carbon dioxide. Carbon dioxide have a long lifetime as comparison to methane, nitrous oxide, and the ozone, because it is in years. Uh, we will talk about it as well. What do you mean by radiative forcing? What do you mean by the global warming potential? What do you mean by the greenhouse gases? We will talk about in next MCQs. Okay, this MCQ is related to the methane, and which is considered as the second most important anthropogenic greenhouse gas, and it is mainly emitted by which kind of sector? So I have four options: automobile, power plants, industrial emission, and the agriculture and waste. So what do you think? From where methane most of the time emit? Alka, Rashmi, will you try to answer? Okay, Rashmi gave me answer D. Alka also gave me answer maybe D. Okay, so yes, answer should be D only. That is agriculture and methane. Sorry, agriculture and waste. Most of the time when we do rice cropping or the rice cultivation, so what happens? Because of the excessive water in the field, there is anaerobic respiration. So anaerobic means in the absence of the oxygen, there is a respiration done by the microorganism that is inside the soil. Okay, so whenever there is an absence of the oxygen, so the byproducts will be, one of the byproduct will be methane, another maybe for example H2S. Okay, and for example ammonia. So like there will be no presence of oxygen, it will not give you carbon dioxide, but because it is the absence of oxygen, that's why it will give you instead of CO2 it will give you the CH4, instead of N2O it will give you the NH3, that is ammonia. So this is because of the excessive water. There will be uh, the soil microorganism can't get the oxygen from the atmosphere. Because of that, the respiration will be done anaerobically, means in the absence of the oxygen, and that's why this will give you the methane production, the first thing from the agriculture. And if you know from this agriculture is also consist of the cattle rearing as well. So whenever there is a dung of the cattle, and there is also anaerobic respiration inside the gut of the animals, and that will also give you the methane production. So obviously agriculture and waste will give you the methane production. Okay, so this is the definition, and the definition says a long-term shift in temperature and weather pattern refers to what? It is global warming or climate change or heat wave or heat island. When there is a long-term shift in temperature as well as in the weather pattern. Rashmi gave me answer B, climate change. Nishant, are you here? You are not giving me today's answer. Okay, Alka also gave me answer B. Yes. So the answer should be B, because it is a shift in temperature, and not only in temperature, but another variable as well. For example, precipitation, rainfall, for example, humidity, heat wave, all this will be covered under this climate change. So whenever there is a change in weather statistics, then we will call it as a climate change. And among that, there are so many variables that can be changed. For example, temperature, for example, precipitation. We will talk about it as well at length. Then the urban center that is warmer than the surrounding, a less polluted area, is known as. And we have three options: cold island, global warming potential, then heat island, and the climate change. Alkan Rashmi gave me answer C, of course. Heat island. This is the definition of heat island. Why? Because of the difference in the reflectivity, difference in the wind movement, that will be different in the urban area and in the rural area. For example, in rural area we have settlements, and that are not that much multi-story settlements. Okay, but in the urban area we have like 20 buildings, 20 multi-story buildings. So what will happen, it can restrict your wind movement. And what will happen when there will be no wind movement, your energy can't be transferred from one place to another place. So the energy that has been released from the settlement will be in the surrounding area only. That may also increase your temperature. The one thing is that. The second thing is, whenever you are designing your rods, that rods are black in color. And you know that if we have black color, the reflectivity will be lesser. Okay, and whenever there is a lesser reflectivity, means it will create the warming condition. So there are lots of reasons. Because of that, urban areas are more heated or more warmed as comparison to the rural area, and this is known as the urban island or the urban heat island. Sorry. So answer C should be the right answer. Then acid rain results when two chemical species are emitted into the atmosphere and react with the atmospheric moisture and oxygen to form acids. So this question is related to the acid rain. So when two chemicals will react with the moisture and oxygen, so that will lead to the formation of acid rain. So you have to tell me which two species or which two chemical species. Nishant and Alka gave me answer A, that is sulfur oxide and nitrogen dioxide. Rashmi gave me answer A. Yes, obviously, whenever we have the sulfur dioxide in the presence of moisture and oxygen, that will be converted into the sulfuric acid, the first thing. If you have nitrogen dioxide in the presence of moisture and oxygen, it will give you the nitric acid, and these two are acid. And whenever there will be the rainfall or the precipitation, that acid will come on your surface, and you will call it as a acid rain. So obviously sulfur dioxide and the nitrogen dioxide. So answer A should be the right one. Okay, what will be the effect of this acid rain? So it will leach out something from the soil. Okay, and that would result into toxic effect to the root tip, leading to root stunting, accompanied by reduced water and nutrient uptake. So I have four minerals or four elements: aluminium, mercury, zinc, chromium. So you have to tell me which one get leached by this. Uh, Alka gave me answer C and Rashmi gave me answer. Sorry, Alka gave me answer A and Rashmi gave me answer C. Nishan, do you want to try for this question? Okay, so answer should be A, and this is the aluminium. And why aluminium? Each element have different characteristics, so the solubility of different elements is different. So aluminium have that characteristics that whenever there is a acid, so it will dissolve very rapidly into the acidic chemicals. Okay, so because of that, because of the easily being dissolved by the acid, it will leach into the soil, and that's why root will not get. So this is also toxic in nature. Okay, so that's why this will give you the root stunting. Okay, so this the answer should be aluminium. Okay, so that was based on the previous assignment question. So now we will talk about topic by topic and some MCQs, and we will try to understand what do you mean by these different topics. Okay, so this question is related to the ozone layer depletion. So we have two type of ozone, right? The one is good and second is bad. And these two type of ozone are at the different atmospheric sphere. So you have to tell me which one is the good and which one is the bad, where it it is present. Okay, so you can take your time. Rashmi gave me answer B, that is second and third. Okay. Alka, do you want to try for this question? We have two type of ozone, good and bad, at two different sphere. So where this good ozone is present and where this bad ozone is. Okay, Rashmi gave me right answer. The answer should be B. And like you know the vertical profiling of the atmosphere. At near to the surface, we have troposphere, right? Above to it, we have the stratosphere. Above to it, we have the mesosphere, and above to it, we have the thermosphere. So we have four sphere of the atmosphere with the, and this will be like With the height, the sphere will be changed. Okay. So if we talk about this good ozone and bad ozone, so that are one is present in the troposphere and one is present in the stratosphere. Okay. So you have to like answer the question was related to where the good ozone is and where this bad ozone is, right? So here we can see that in this figure, that in the troposphere, like very near to the surface, we have ozone, that is the tropospheric ozone, and that tropospheric ozone leads to the smoke and the photochemical smoke, even the pollution. Okay, so that's why it is the bad ozone. Bad ozone will be present in the troposphere. But if we will talk about the ozone that is present in the stratosphere, this will protect us from the ultraviolet radiation. Okay, so we will talk about this ultraviolet radiation as well. So because it protects us from the ultraviolet radiation, that's why the ozone that is present in the stratosphere is the good ozone. So the answer should be the stratospheric ozone is good ozone and the tropospheric ozone is the bad ozone. Okay. The next question is, as you saw the figure and from that figure only you can tell me what is the height where most of the stratosphere ozone is located. So you'd have to tell me at what height most of the stratospheric ozone is present. So we have four options: 0 to 15 kilometer from the surface, then 50 to 30 kilometer, then 30 to 45 kilometer, and 45 to 60 kilometer. Rashmi gave me answer D. Nishan, do you want to try this question? Anka? Okay, B. Okay, from here you can see like here as well we can see we had four sphere: troposphere, stratosphere, mesosphere, and thermosphere. And this stratosphere is basically from 10 or let's say 15 kilometer to 15 kilometer to 50 kilometer. And we already have discussed that good ozone is present in the stratosphere. So among the options, B should be the right answer. That is 15 to 30 kilometer. This stratospheric ozone should be present. Okay, so we are just now talking about the good ozone. Okay, now the question is about the SI unit of the ozone. You know that in the stratosphere, good ozone is present, but what is the unit of measuring that ozone? So we have four options: meter, decibel, Dobson, watt per meter square. So you have to tell me the unit by which we can measure the ozone. This is very simple question. What is the unit? How do we measure this ozone? If there is a ozone hole, then how did we go get to know that there is a hole? Because we measured. So how did we measure this? What is the SI unit of the ozone? You can try. You can like you can cancel out some of the options, and then you can get at least one or two. Rashmi gave me A. Okay. Alka gave me answer C. Okay. Actually, the answer is C, that is the Dobson. But I will not say that meter is also wrong. Meter, like Dobson is also the unit of the length, and meter is also unit of length. But yes, if we are talking about the SI unit, then obviously this is Dobson. But both the Dobson and meter, because these two units measure the length only, and That's why I will say that no doubt the unit, SI unit of this ozone is Dobson. But if it is not the SI unit, it is just the unit of the ozone, then meter can also be the right answer, because both these units are related to the length. Okay, we will talk about it as well. So the answer should be Dobson, uh, C answer. And here we can see that, as I told you, that in the stratosphere, ozone is present, right? And at some height. So you have to see the thickness of the slab. So because ozone is presented with some thickness. Okay, so we have to measure that thickness, and that thickness is nothing but the length. Okay, that's why I told you that meter can also be the right answer. We were talking about the SI unit, so it was the Dobson. So if it is the thickness, all of the above should be included in this option. Yes, I could have included, but because I asked the SI unit, then Dobson should be the right answer only. Okay, so that's why I didn't include all of the above. Uh, okay, so this is the thickness, right? So what thickness we have of the ozone, that will be measured in mm, and then we will convert it into the Dobson. Okay, and there was one scientist, that is GMB Dobson, in 1936. He was the first scientist that investigated about the atmospheric ozone. Okay, so here you can see like how we can measure this. Like this is just the thickness of the slab. Uh, then there is something I wrote about this scientist. So the scientist Dobson was an experimentalist of unusual ingenuity who devoted most of his life to the observation and the study of the atmospheric ozone. And he also tried to understand why there is increase of temperature with the height. As I told you, like I had one, yeah, here we can see that in the troposphere, whenever there is a increase in the height, the temperature is decreasing in the troposphere, because we also know that whenever we go higher at the altitude, the temperature decreases. Okay, but in the troposphere, with the increasing in the height, the temperature is also increases. So the scientist gave the theory why this is happening, why there is an increment in the temperature with the height. So he told that because there is the ultraviolet radiation, and this ozone layer will absorb that ultraviolet radiation, because of that the temperature will be increased. So he gave the reasoning for that. Then he also lead it to an understanding of the structure and the circulation of atmosphere. What is the structure, how this stratosphere circulates. Okay, what type of gases the stratosphere has. So such kind of things he revealed. Okay, and then in 1923 he produced the first Dobson ozone spectrometer. So uh, he created a instrument by which we can measure this the ozone. Okay, so this was all about the Dobson. The next question is, because I told you that this Dobson is the measure of the length. Okay, and one Dobson unit is defined to how much thickness at STP, that is the standard temperature and pressure. So one Dobson unit is equal to how much millimeter? What should be the answer? Can you get some idea from this? It forms a slab 3 thickness corresponding to 300 DU, Dobson unit. Can you guess something from that? And can you give me answer for this? Okay, so Answer is 0.01 mm. So if we are talking about one Dobson unit, so we are talking about just 0.01 mm. So you can see like how much small unit we are talking about. Okay, so this is very smallest unit of the length. That is the Dobson unit. And here by this figure, we can see like the average global ozone we have. This is mostly 300 Dobson unit, and 300 Dobson unit is equal to 3 mm. So 3 mm is just putting three coins together, one above, one to the above. Okay, so that much thickness of the ozone we have in the stratosphere at the STP, that is the standard pressure and temperature. So this is again the question, like what is the global average ozone we have around in our atmosphere. So this is 3 mm, or we can say 300 du, that is the Dobson unit. And because of the ozone hole, our average ozone sorry because of this hole was nothing but the decrement in the thickness of our ozone. So this leads to the thickening of 1 mm of ozone. Okay, so you must know this number 300 du and the 100 du. 300 was the average ozone concentration we have, not concentration but the thickness. And whenever we are talking about the ozone hole, then what thickness we are talking about? So this is 1 mm, just 1 mm. But this is that much important that we have to uh, we have to have to stop the use of so many ozone depleting substances, because we will talk about it. We have different type of ultraviolet radiation, and impact of ultraviolet radiation on human skin, on human DNA is very very like serious. Okay, so we will talk about this as well. Okay, so we have, because I told you stratospheric ozone is a good ozone, and why it is? Because it will absorb the ultraviolet radiation and it will not let the ultraviolet radiation to go on the surface. Okay, surface of the earth. So you have to tell me what range of that ultraviolet radiation is captured by the ozone layer. We have three type of ultraviolet radiation, A, B, C, and these three type of ultraviolet radiation have three ranges of the wavelength, and you have to tell me which range is being captured by this ozone layer. So the options we have is 100 to 180 nm, 180 to 260 nm, 260 to 350 nm, and more than 350 nm. And you have to select the right answer. This is something out of the box question, but yes, you people should know what range of wavelength the ozone captures. Can you guess? Okay, so answer is first and second. Nishan, we will talk about this. Why this is first and second? So let's talk about it. So here we can see we have three type of ultraviolet radiation, A, B, C, and we can see that violet radiation A can go up to the epidermis. Ultraviolet B, epidermis is nothing but the beneath of the skin. Then ultraviolet radiation B that can go up to your skin surface, and the ultraviolet radiation C that is already been absorbed by the stratospheric ozone. Okay, so you got to know that if it is the ultraviolet radiation C, then this will be already captured by the ozone. Okay, then another is these three type of ultraviolet radiation have different range. So uh, we will start from the C, because C has the highest energy. the one question will be, whenever there is a lower wavelength, then it means we are talking about the higher energy wavelength, right? So whenever it is a 100 nm, means it is a very like the intensity of energy is very high as comparison to the 400 nanometer. Okay, so because the energy of this ultraviolet violet radiation C and B is higher than A, then this can be very destructive in nature. And we can see that C has been absorbed by the stratospheric ozone. B has been partially absorbed ultra, stratospheric ozone, and this ozone doesn't uh, like can't block this ultraviolet radiation A. And the wavelength is higher, and that's why it is not that much destructive to the human body. So the answer should be like, because it is completely restricting the UV radiation C, partially restricting the UV radiation B, and it is not restricting the UV radiation A. So answer should be uh, here A, first and B, because the wavelength that are shorter will be absorbed by the stratospheric ozone. And here we can see, like, this is the another example where you can see, like, most of the ozone layer can capture this ultraviolet radiation C, then partially B, and can't capture this ultraviolet radiation A. And different type of radiation have different impact. So for example, if we are talking about ultraviolet radiation C, then this is extremely dangerous, and it is blocked by the ozone layer. If we are talking about B, then it can cause the skin cancer. It can also cause this cataract, that is the eye related problem, and then the sunburn. But if it is the A, then it can lead to the premature aging, the wrinkling of the skin, and the implicated in the skin cancer. So we have to restrict this ultraviolet radiation C and B in the maximum amount. And whenever there is a not ozone and the ozone layer has been thickened, then this ultraviolet violet radiation C can enter into the atmosphere and can reach to the surface of the earth. And because of that, we can get like, this is very dangerous, because such kind of radiation can interference with the DNA of our body as well. And so you can just think how much dangerous it is. Okay, then there is a one law that defines the relation between temperature and the wavelength, and you have to tell me what law we are talking about. So I have option Wien's displacement, the second is Planck law, the third is Kirchhoff law, and the fourth is Stefan Boltzmann law. As I told you, whenever there is the wavelength is shorter, means the energy is very higher. Whenever there is a higher wavelength, means energy is lower. And there is also some relation between wavelength and the temperature as well. So what kind of law? Rashmi gave me answer B, that is the Planck law. B maybe A. A or D? Okay, so answer is A. That is the wind displacement, and I just tell you how it is. So, for example, because like, we have two different scenario. The first is the sun, okay, and second is Earth. Okay, sun has the temperature of approximately 5800 Kelvin, right? So whenever there is a higher temperature, that will give you a very the radiation that has a very short wavelength. Okay, that means temperature is inversely proportional to the wavelength. Whenever there is a higher temperature, that will give you the higher intensity radiation, means a lower wavelength. So wavelength is inversely proportional to the hello Pinak. It's all right to joining the late. So we were talking about there is a relation between temperature and wavelength, and that is the inversely relationship, and that inversely relationship has been explained by the wind displacement law. So whenever there is an increment in the temperature, the curve of the wavelength will be higher near to the shorter wavelength. So that's the reason why most of the time, or like 100%, whenever the sun is radiating the energy, or sun is radiating the sunlight or the radiation, the wavelength is very low. Means it is giving you the radiation mostly in the visible range. Okay, but because we know, as comparison to the sun, the temperature of the earth is nearly low. Okay, because it is 25 degree, average is 25 degrees Celsius, and because of that, most of the time earth will emit the radiation in the infrared radiation, and infrared radiation have the higher wavelength. Okay, so there is a inversely proportional relationship between temperature and the wavelength. And we have one formula that whenever we have the wavelength, then we can calculate the temperature. And how we can calculate this? Wavelength is proportional to, or is equal to 2898 upon the temperature, that is in Kelvin. Okay, so likewise you can calculate the wavelength whenever there is a temperature. uh, Today's question is almost out of the lecture material and more logical. Yes, I thought that you should know something about ozone and radiation. What do you mean by this? So that's why I gave you such kind of question. So this is the wave displacement law, right? Here we can see, like, there are different radiation. This is the electromagnetic spectrum as you studied in your 10th to 12th class. So from ultraviolet radiation C to B to A to visible to infrared, the wavelength will be increased. Whenever there will be increment in the wavelength, means energy will be decreased. Okay, and that's why based on the temperature you can tell, like, you are talking about which range of the radiation. Okay, so this was all about the relation between that. Rashmi, I don't know about this, but I just know that these questions are very much related to the content that has been covered. That's why I put such kind of questions. Okay, the next question is, which form of the oxygen is or are involved in ozone oxygen cycle? So this is atomic oxygen, then the oxygen O3, O2, O3. So you have to tell me which one is this. Pinak gave me answer A, the first, second, and third. Because you know that if there is a, like, the creation or the formation of the ozone and the destruction of the ozone will lead to the formation of some chemical species or some oxygen species. So you have to tell me what form of oxygen we are talking about in the ozone oxygen cycle. So yes, answer should be A, that is first, second, and third. And here it is, like, whenever there is a there is a oxygen.
Ma'am, what is the usual name of means chemical name of O2O5? Means like pentaoxide oxygen, something like that.
This was nothing. I just wrote as usual, like without any meaning.
No, I think there is like a compound.
There is a compound like N2O5 and all, but
No, ma'am.
there is no such
Like
compound O2O5.
okay. Yes, ma'am.
Like it should be O7, right? Why did I write this O2O5? I don't know, but yeah, this is nothing. So yes, if we were talking about the solar radiation, then uh, to break this oxygen, we have to have the wavelength in the range of less than 200 nanometer. Means this will be the ultraviolet radiation C category, right? So whenever you have the ultraviolet violet radiation C category, that will break down this oxygen into two atomic oxygen. Okay, and whenever we have one atomic oxygen, that will react with the oxygen, that will give you the ozone. So here there is the formation of the ozone. But whenever there is a destruction, then the wavelength of that radiation can be from 200 to 300 nanometer, and that will break down this ozone into oxygen and the atomic oxygen, and then one atomic oxygen will react with the ozone, and that will give you the O2. So the this is how we can destruct the ozone. So here we can see we have three species: atomic oxygen, then the oxygen, and then the ozone. So that's why the answer was A. Okay, so we talked about the stratospheric ozone. Now there is a one question about the tropospheric ozone. Uh, for the formation of the tropospheric ozone, we must have some precursors. So you have to tell me what kind of precursors can lead to the formation of the tropospheric ozone. So I have options, that is the NOx, SOx, volatile organic compounds, aldehyde, and the carbon monoxide. So you have to tell me which one, which answer is right.
Ma'am, mostly the troposphere layer contains the NOx and SOx, so I think A will be the answer, first and second.
You have to like a little bit study about how the like this is related to the photochemical smoke. So for that photochemical smoke, it is not necessary to have the presence of both of these gases. So this is related to something else as well.
So maybe NOx and VOCs.
Yes, answer should be B. That is NOx and volatile organic compound. Here you can.
Because NOx is included in atmospheric titration, while I was in doubt of SOx. So yes, NOx and VOCs.
So for the formation of photochemical smoke, the precursor gases are nitrogen monoxide, nitrogen dioxide, volatile organic compounds. Okay, in the presence of these kind of gases, even in the presence of sunlight, there will be the production of the secondary pollutant, and ozone is one of the secondary pollutants. Okay, so and this will also give you the photochemical smoke by which you can feel the hazy and the visibility. uh, Answer is B. That is first and third, NOx and volatile organic compound. So uh, so that's why answer should be that B only. Okay, so this is very simple question. Why is the status tropospheric ozone is considered as a bad layer? So we have four options that is leading to the smog formation. It is a potent greenhouse gas. It leads to the formation of acid rain, and it leads to the tire cracking. So you have to tell me which one is the right answer.
Ma'am, according to me, answer, I'm not sure about fourth option. While you said about the photochemical smoke, so first statement is true. Regarding the greenhouse gas, yes, in troposphere it acts as a greenhouse gas, which is known as bad ozone. And third, yeah, NOx is included, so acid rain will be sure. So answer will be C according to me, but it may be E because I'm not sure about fourth, the tire cracking.
We were talking about the tropospheric ozone, but we are not talking about the nitrogen dioxide here. We are talking about just about O3, that is the ozone. So it leads to the formation of acid rain is not right, because like NOx is related to the acid rain, because NOx is the precursor for the formation of the ozone. But if there is a ozone in the atmosphere, so what will happen then? So the question is related to that only. Someone gave me answer. Rashmi gave me D answer. Okay. Yes, answer should be D. The first is it will lead to the smoke formation, because I told you that this is the important component that will lead to the photochemical smoke. Okay, that will give you the hazy and will reduce the visibility of your atmosphere. The first thing. The second is, yes, it is the potent greenhouse gas. We will talk about it as well. It can also absorb the long wave radiation that are coming from the surface. Okay, and that's why it is also the greenhouse gas. It can also increase your temperature. The third is, it is leading to the formation of acid rain. No, acid rain is related to the SOx and NOx, but right now we are talking about the ozone. So this will be not the answer. Then it leads to the tire cracking. Yes, because of the ozone, because of the double bond in the ozone, and because there is, because there is a double bond in the tire formation. Okay, if you will see the formula of the tire, how tire is formed, then there is a double bonded structure. Okay, and that bond can be easily break down by the ozone, and that's why in right now, in most of the time, in the summer time, basically tire can be cracked, and this is nothing but because of the ozone concentration. Okay,
And
so
tire
also,
contains vulcanized sulfur, na?
what?
Vulcanized rubber. Tire contains the sulfur means in a vulcanized form.
It also contains the sulfur as well as the C compound or the carbon compound bonded by the double bond. Okay, and the important thing is that that double bond will be break down by this ozone layer. So that's why there can be the tire cracking due to the ozone that is present in the troposphere. Here we can see that why I told you that, because ozone is the greenhouse gas. Why it is? If we can see that ozone has the potential of 2000, means it is more stronger, 2000 times more stronger than the carbon dioxide. Okay, so you can see like how much potent it is as a greenhouse gas. The next question is, the main cause of ozone hole and its depletion is. So right now we talked about how this ozone is forming, how this ozone has been destructed, where by which radiation it can form, what kind of radiation it has, it absorbed, it captured. Now we are talking about the ozone hole. So you have to tell me what is the main cause of this ozone hole and its depletion. Pinna gave me answer D, that is all of these. Alka, do you want to give me answer? Santosh gave me answer D, all of these. Okay. Rashmi gave me halocarbon refrigerants. Okay, so answer should be D. Why? We will talk about this because whenever we are talking about the propellant or the foam blowing agent or the halocarbon refrigerator, each of these kind of agents has some component that is common, and that is nothing but the halocarbons, that is the chlorine, bromine, and the fluorine. Okay, whenever there is a three compound, chlorine, bromine, or the fluorine into our compound, that can lead to the depletion of the ozone. I show you. Okay, so we have propellant, and I gave you like five propellant, that is CFC 11, CFC 12, 114. This is the terminology based on how much number of carbon or the hydrogen or the fluoride you have. Based on that, we have some number, that is 11, 12, 114. And if we can see the ozone depletion potential, so ozone depletion potential of CFC 11 is 1, 12 is 1, then 114 is zero point 0.7. And if we are talking about HFA and HFA different components, then ozone depleting potential is 0. uh, you can have this link on a link on NPTEL itself, Santosh. Then if we see that most of these propellant or the blowing agent have a very long lifetime, and that is in hundreds. For example, for the CFCs it is the 60, but for the CFC 12 the lifetime is 125. Means that that particular species can live into your atmosphere for 125 years. So how much depletion it can do for this ozone is very higher. Okay, then for the
Ma'am,
refrigerants,
ozone, ma'am,
yes.
ODP, ozone depletion potential in HFA, it is written zero, ma'am. It can't be zero, ma'am. It can be a small value like 0.00, but I think it cannot be zero, ma'am.
You have to check it. I took it from only Wikipedia, so you can check it at once, right? But right now we like most of the time there was chlorine or the bromine.
Yeah, right now we are using hydrofluoro instead of
Yes,
chlorine.
yes.
But
So
it cannot be like ozone depletion potential is zero. It may be a small value like 0.00, but
Pinak, you can check it because I didn't
yes,
care
ma'am.
about this much. But I'm just showing you the whatever I got from the Wikipedia, right? Then we have the blowing agent and then the refrigerant, most of which have the fluorine and the chlorine. And if we have the fluorine and chlorine, that will give you the ozone depletion. Okay, so that's why D was the right answer. Here is the mechanism by which this fluorine and chlorine. Most of the time, it is not the fluorine, but it is the chlorine that is depleting the ozone. So how it is? So, for example, we have one compound that have three chlorine, okay, and one fluorine that is attached to the carbon. Okay, what will happen whenever there will be the ultraviolet radiation? That ultraviolet radiation will detach one chlorine. Okay, so one chlorine will be breaks away. Then if it is a free chlorine, that this free chlorine will be attached to the ozone. Okay, what will happen? This will form uh, the ClO, one intermediary compound. Okay, and then what will happen? This will then what will happen? There will be one atomic oxygen that will react with the ClO, and this will release the chlorine. This will free the chlorine. So now we have the chlorine as it is, and this ozone has been broken down into the oxygen. Okay, and because right now we have the free chlorine, thousands of time, lakhs of time, this chlorine can break down thousands of ozone atoms, ozone molecules, sorry. So you can see how much this one, only just one chlorine can break down our ozone and will lead to the ozone depletion. So this is the mechanism. The next question is, ozone can be destroyed by the following free radicals. So we have some radicals by which we can destroy the ozone. So you have to tell me the radicals. So the chlorine radical, hydroxyl radical, nitric oxide radical, and all of these. Rashmi gave me answer D. Answer should be D, because this is not just the chlorine, but if there is the hydroxyl radical or the nitric oxide radical, you have to study more about this, how these different free radicals can lead to the depletion of the ozone. So D is the right answer. Okay, then greenhouse gas causing a rise of 3 degree Celsius rise in the overall global temperature in the past centuries are CFCs. The CFC used in refrigerator is. So you have to tell me the name of that CFC, that chlorofluorocarbon that is being used for the refrigerator. Give me answer freons. Rashmi gave me freon, Santosh gave me freons. Yes, so Alka, some of the question I prepared myself, and some of the question I most of the time take from this Baiju and all. Then yes, B is the right answer. That is the freon. Then ozone depleting substance chiefly utilized in. So you have to tell me why do we use the ozone depleting substances? Why do we use the CFCs? What is the use of that CFCs? Are we using it in the chimney, or we are using it in the human activities, or the burning fossil fuel, or cooling, or the refrigeration applications? Yes, Pinak, I will share you. Yes. Can you tell me where we can use this CFCs? What is the use of the CFCs? Are we using it into the chimneys? Yes, Rashmi, I can send you the topics for this, like notes for this. Yes, answer should be only fourth, because most of the depleting substances are used as a cooling or the refrigerant, as a refrigerant chemicals, and these are manufactured in the manufacture of the foam products. Okay, so answer B should be the right one. And okay, so we talked about the Dobson unit. We talked about how much Dobson unit we have for the ozone. What is the average thickness of the ozone we have in the atmosphere? Then what do you mean by the ozone hole? So what Dobson we have whenever there is a decrement in the thickness of this ozone? So we talked about this, right? Then there are some conventions, and because we were worried that yes, ozone thickness has been decreasing, because of that most of the ultraviolet radiation C was entering into the surface, and because of that we had a lot of like adverse impact on our human health, even on animals, even on plants. Okay, that's why we want to like we had the concern how we can stop, how we can recover this ozone hole. So there are some conventions. And okay, there is one question that this is the major risk linked with the extreme ultraviolet radiation through the atmosphere as a result of ozone layer depletion. So what kind of disease you may have whenever there is extreme ultraviolet radiation? Rashmi gave me answer D, that is increased skin cancer. Pinak also gave me yes. Right now we are using the sunscreen, right? And in that sunscreen, you have seen that there is there is a written SPF more than 50. So what do you mean by SPF? Have you noted, like whenever you are buying some sunscreen, then there is a written SPF, and SPF more than 50 or more than 25. What do you mean by that? Have you read about this SPF whenever you bought some sunscreen? So this is nothing. Yes, Pinak, you were saying something.
I'm not sure, but I'm just guessing that skin protection frequency.
Not frequency, but yes, factor.
Okay, skin skin
And not
protection.
not skin. This is sunlight.
Oh, yeah, yeah. Okay, okay.
Okay, so like how much radiation in it can uh, that layer of the sunscreen can restrict the interaction of ultraviolet radiation with your skin, because of that ultraviolet radiation you can have the skin cancer. So the sunscreen have some role, and that role is it can restrict the contact of this ultraviolet radiation with the skin, so that we can avoid such kind of skin cancer. Okay, so that's why D should be the right answer. Because of ultraviolet radiation, increased skin cancer is the main concern. Okay, because we talked about that, we were concerned about how to recover, how to heal the ozone. So the question is, the Montreal Protocol is related to food
Ozone layer depletion.
security, global warming, sustainable development, ozone layer depletion. Tina gave me answer D. Alka also gave me answer D. Rashmi also gave me answer D. Yes. So because we were concerned, we had some kind of meeting or the convention by which we want we want to have some laws by which we can give some direction to all the countries how should we proceed to just heal our ozone layer. Okay, and there was one protocol, that is the Montreal Protocol, that was related to the ozone layer depletion, right? Okay, so you have to tell me when this Montreal Protocol came into. So, in which year?
From 1989.
You can guess. Rashmi gave me right answer. This is 1987. So, it was in 1987 that Montreal Protocol came into effect, right? Okay, so I have something. I think the text is very small, but you should know that in 1970s and 1980s, the international community became increasingly concerned that ODS, that is the ozone depleting substance, would harm the ozone layer. Okay, so there were some concern in 1970s and 80s. So because of that, in 1975, SC Johnson announced corporate phase out of CFCs as aerosol product propellant. Okay, so there was one company that told that we will phase out the CFCs. Then in 1976, United Nations Environment Program, that is UNEP, called for the international conference to discuss an international response to ozone issues. So how should we respond to such kind of issue? That was like there was some call by this UNP in 1976. Then in 1978, US banned non-essential use of CFCs as the propellant in some aerosols. For example, in hairspray, in deodorant, and the um, antiperspirant. I don't know about this. Anyway, but Canada, Norway, and Sweden also followed the same ban. Okay, so and in 1981, UNEP developed a global convention to protect this ozone layer. 1987. So this was the important date. 24 countries signed this Montreal Protocol on substances that deplete the ozone layer. 1989, all developed countries that are the party to the Montreal Protocol banned the products and the consumption of CSCs at 1986 levels. Okay, and then there were a lot of reforms and the amendment that has been happened. Like there were a variety of CFCs, and some of the CFCs were important. Okay, some of the CSV were the integral part of our refrigerant or our AC. So step by step, we had to replace these. Okay, so for example, in here we can see that from 2004 to 2010 to 2015. So here we can see that HCFCs has been reduced by 35%, then 65%, then 90%, and we are expecting that HCFCs will be removed completely by 2040. Okay, so these were the amendments that has been taken, and step by step we are just trying to recover our ozone layer so that ultraviolet radiation can't reach on the surface of the earth, right? Okay, because some of the good people studied about this ozone hole. They talked about the mechanism by which ozone has been depleted, and because of that, they got the Nobel Prize. So you have to tell me the name of that scientist. So there were three scientists. So you have to tell me the name of that scientist who got Nobel Prize, who discovered that CFCs and N2O can break down stratospheric ozone. Who were they?
Ma'am,
Yes, Maheshwari.
ma'am, give you your phone number, ma'am.
Uh, can you write me on the mail only because it is not good to share
Give
on
me
the
mail, ma'am.
what?
Mail ID.
Yes, I'm writing mail ID in the chat box.
Write it message box, ma'am.
Uh, what Maheshwari?
Message box.
Yes,
Jo
yes, yes. I
21
dropped my yes. I dropped my mail in the chat box.
chat box. Another one time, right, ma'am?
What, Maheshwari?
Second time,
A second time what?
right, ma'am? I'm not understand first time.
I didn't understand. Like, what do you want to say?
Jyoti21 at iiserb.com.
Yes, ac.in.
At iiserb.com.
.ac.in, not com.
Serb.com. iiserb.in.
.ac.in.
Okay, ma'am. ac.in.
Yes,
.ac.in.
yes.
Thank you, ma'am.
Okay, Maheshwari. So I saw some answer. Alka gave me answer C, first, second, and third. Answer is the C, and the Nobel Prize was given in the chemistry, and in 1995, and these were three scientists, Paul Crutzen, then Molina, and Roland. These are so famous because these were the three scientists who told like CFCs were the culprit who that species depleted our ozone. So you should salute such kind of scientists, right? Okay, but he's female. Anyway, UV rays is higher in summer. Why? So during summer, ozone is more in the atmosphere. Sun is busy in summer, especially. Sun is closer to planet Earth, so rays have the shorter distance to travel and reach us, and none of the above. Answer should be C. Answer should be C. Sun is not busy in summer, but yes, sun is closer to our planet. That's why we have a higher concentration of ultraviolet radiation. Yeah, in the summertime. Okay, so these all questions were related to the ozone. What do you mean by ozone depletion? How ozone can be depleted? How we can measure the ozone, and how this ozone is formed and the destruct. Alka, why not A? During summer, ozone is more in the atmosphere. This is not the case. We were talking about the stratospheric ozone, right? And like this is the UV rays that is higher in the summer. This is not because of ozone. This is because UV radiation has been radiated by sun itself. So this is not related to the ozone, and ozone is more. So that's why C is the right answer. Okay, so right now we have some question about the global warming. Okay, because we have covered the ozone layer depletion. So we have some indicators to see the intensity and the possible impact of global warming, and you have to tell me what indicators we are talking about by which we can measure the intensity and possible impact of the global warming. Ishan gave me answer D, that is all. And also gave me answer D, all of the above. Pinnock 1 and 3 only, 1 and 3. Okay, so obviously answer is D, that is uh, global warming potential, then the radiative forcing and the AGGI. We will talk about this, how these are three indicators. The first is global warming potential, right? Global potential means how much potential a greenhouse gas has to increase the temperature, right? Then the radiative forcing. So because of some particular gas, it like we have two type of radiative forcing, positive and negative. Whenever there is a positive, positive means uh, we have the net radiation that is positive, means the outgoing radiation is lesser as comparison to the incoming radiation, then it is a positive. And it may be because of the some gases, because of the some greenhouse gases, and because whenever there is a positive radiative forcing, it means there will be the warming. Okay, whenever there is a negative green radiative forcing, it means there will be the cooling effect. So that's why this is also the indicator. Then very much related to the radiative forcing is the AGGI. We will talk about it, how we can calculate this AGGI from the radiative forcing. So these three of these are the indicators. So the D should be the right answer. Okay, so next question is, this is very basically the greenhouse gases in the atmosphere block which type of radiation? Short wave radiation, long wave radiation, infrared radiation, X-rays. So whenever you are talking about the greenhouse gases, so what is the mechanism of that? How it can lead to the warming condition? So this question is related to that only. So what type of radiation are being absorbed by the greenhouse gases? Is it short wave, it is long wave, or it is infrared, or it is the X-rays? This is one of the simplest question. Whenever we are talking about greenhouse gases, then this is very important. Rashmi gave me A, that is first and third. Okay. Will anybody else attempt to give the answer of this? Come on, guys. We already we were talking about greenhouse gases and what's the role of that greenhouse gases. Why greenhouse gases is leading to the temperature increment? Yes, Pinak, infrared radiation is one of the option. B is the right answer. Infrared radiation and the long wave radiation. Infrared radiation is the part of the long wave radiation. And if you know that, as I told you, whenever there is a sun that is radiating the radiation, that will be in a short wave radiation. That would be short wave radiation. But whenever the radiation will be emitted by the earth, that will be the long wave radiation, and that is based on the temperature, because the sun temperature is very higher. That's why it will give you a very short wave radiation, because the temperature of the earth is though not that much hotter. That's why it will give you the radiation that has a long wave. Okay, so as this one, yes, here we can see that short wave radiation are being emitted from the sun, but from the earth long wave radiation are being emitted, and this long wave radiation, infrared radiation is the part of this long wave radiation. Okay, so here we can see in the second picture, sun has given the light. Okay, the greenhouse gas will not restrict the short wave radiation that are being emitted by the sun. Okay, that sunlight will be uh, reflected by the earth's surface, then it will convert into the long wave radiation. Initially it was the short wave, but after reflecting by the sun, it will be the long wave radiation. And because in the atmosphere we have the greenhouse gases, these greenhouse gases will absorb that long wave radiation, and because of that, it will not allow the long wave radiation to go back to the space, and that's why the temperature will increase. And that's why we do say that because of the greenhouse gas, the temperature is increasing, because it is not allowing the long wave radiation to go back to the space. It is just absorbing and radiating back to the surface. So here in the third picture we can see sun is giving you some light. That light will be absorbed by the sun and some will be the reflected. And because the temperature of our our surface is not that much higher with as the sun has, then because of that it will reflect the light in the long wave radiation, and this long wave radiation will again absorb by the greenhouse gases, and this will again will be given to the surface of the earth itself, and this will be the cycle by which absorption of the long wave radiation by the greenhouse gases that will be radiated back to the surface, and this cycle will go on. So a very low radiation will go back to the space, and that's why if there is a more radiation in the atmosphere, that will give you the higher energy, higher temperature, or the higher heat. That's why global warming, the cause of the global warming is the presence of the greenhouse gases, and this greenhouse is absorbing the long wave radiations. Okay, and infrared radiation is the example of the long wave radiation. Okay, so you have to tell me the name of the greenhouse gases. I have 6 options, and you have to tell me which gases are the greenhouse gases. Okay, give me answer D. Okay. B, but not sure about ozone is bad or good. We are not talking about bad or good, but we are talking about the greenhouse gas. The greenhouse gases are nothing that have the potential to absorb the long wave radiation. So the answer should be related to whether the uh, ozone is absorbing the long wave radiation or not. Answer should be D, because not only ozone, but water vapor, fluorinated gases, all of these are the greenhouse gases. All these kind of gases have the potential to absorb the long wave radiation. Okay, and so answer D is the right. If you see here, whenever there is the rays that will be given by the sun to the surface, then it will be reflected back, and that gases will be absorbed by carbon dioxide, methane, CFCs, ozone. Here ozone is that is present in the troposphere, not in the stratosphere. Okay, and then the nitrous oxide and more gases. So such kind of gases can absorb the radiation that has been reflected from the surface. Okay, and that will radiate back to the surface of the earth, and that's why it will give you the warming effect. And because water vapor is also the global also the greenhouse gas. Why? Because whenever there is the water vapor in the atmosphere, that will also absorb the long wave radiation, and because of that it will increase the temperature too. So there is a positive feedback of the water vapor as well. So that's why the answer should be all of the above. So you must know the list of the greenhouse gases, and the potential of each of the gas. We will talk about it as well. Okay, so the greenhouse gas ability to trap an extra amount of heat in the atmosphere or time related to 1 ton of carbon dioxide emission is known as. So the global warming potential, radiative forcing, annual greenhouse gas index. Shan gave me answer A. Rashmi also gave me answer A. So this is related to how much powerful your other gases are as comparison to the carbon dioxide to capture the long wave radiation. So this is known as the global warming potential. Answer should be A. This is somehow I by mistake wrote here D, but answer should be A. That is the global warming potential. So here we can see that we have different gases: carbon dioxide, methane, nitrous oxide, perfluorocarbon, hydrofluorocarbon, and the sulfur hexafluoride. Okay, so here we can see like how much equivalent it is to the CO2. So here we can see like carbon dioxide is equal to like if it is a 1 kg carbon dioxide, then it is equal to 1 kg carbon equivalent. But if it is a 1 kg methane, then it is equal to 25 kg carbon dioxide equivalent. If it is nitrous oxide, if it is a 1 kg of nitrous oxide, then it will be equal to 298 kg carbon dioxide equivalent. So this is nothing but this is showing you how much powerful it is with respect to the carbon dioxide. Okay, how much powerful these gases are to absorb the long wave radiation and to give you the warming effect. And greenhouse this global warming potential can be calculated by this formula. Here F is the radiative forcing, C is the concentration of that gas, then here tau is the residence time of or let's say the lifetime of that gas, and T is for how much time period you want to calculate this global warming potential. And here denominator has all these value related to the carbon dioxide, so by which you can calculate the global warming potential. So this is by which, because for example you know that nitrous oxide is approximately 300 times more powerful than the carbon dioxide. So there may be some mechanism by which if we can remove this nitrous oxide very efficiently, then a large portion of the warming we can reduce, right? So this will give you an idea which gas should we target to, right? So this is the global warming potential. Then, okay, which gas has the highest global warming potential? Which gas is more powerful or the most powerful? So we have option methane, nitrous oxide, and then NF3, I don't know what we will call it, and then the SF6. Rashmi and Nishant gave me answer A. If you know that the global warming potential of methane is approximately 21, means it is 21 times more powerful than the carbon dioxide. Can you tell me the global warming potential of SF6, sulfur hexafluoride? It is in thousands. I show you here we have the global warming potential. For the carbon dioxide, it is the 1, because we are comparing the the power of each gas is related to the carbon dioxide. For the CF4, it is 6500 times, then C2F6. Can you see that SF6, this is 23,900 times more powerful than the CO2. So whenever we have a single molecule of SF6 in the atmosphere, so how much powerful it is related to the in relation to this carbon dioxide. So answer should be SF6. Okay, whenever we are taking the methane has the global warming potential of 21. Nitrous oxide has the global warming potential of 310. And this NF3 has the potential of 8,000. Rashmi, this is sulfur hexafluoride, and this is the synthetic gas. This is not present naturally in the atmosphere, but because we people can create a lot of gases in the atmosphere because of our use, because of the over exploitation. So I don't know about the origin, how like what is the use of this SF6, but just I know that this is the anthropogenic gas that has been emitted or created by the humans only, and this has a very higher global warming potential. You can check what is the source of this SF6. I don't know about this. Okay, but SF6 has the highest global warming potential. Okay, the next question is, a shift in the energy balance caused the Earth average temperature to become warmer and cooler, and it is known as what? Radiative forcing, energy budget, net gain radiation, and the net loss radiation. Okay, I think two answer already have been given. Nishant and Pinnak gave me answer A, radiative forcing. Okay, so obviously answer is A. So what do you mean by radiative forcing? At the top of the atmosphere. So wherever there is the end of the atmosphere, you calculate how much radiation has been come into the atmosphere and how much radiation has been go out from this atmosphere. So you will minus it and you will get the radiative forcing. So this is the shift in the energy balance. For example, initially sun is giving you a 100 watt meter square per meter square, and because of the greenhouse gases, C and D options are the part of the formula. Yes, you can say that yes, it is the part of the formula, but the terminology is nothing but the radiative forcing. Uh, then yes, the radiative forcing, whenever it is positive, then you will say that yes, it is the net gain radiation, and whenever there is a negative radiative forcing, then you will say that it is the net loss, right? uh, Here I have one picture. Yes, so whenever there is the incoming radiation, so you will calculate it how much radiation are going back from the atmosphere, and because there is some energy embedded in the radiation, so that's why we are talking here about the watt per meter square, right? So how much watt per meter square has been added or has been lost, we will calculate it like the incoming minus outgoing radiation, and that will be in my watt per meter square, and then we will calculate the radiative forcing. Okay, because of some because of some greenhouse gases, our outgoing radiation may be higher. Okay, and that's why whenever there is a positive radiative forcing, then we will say that this is giving you the warming effect, right? uh okay, so here we can see like do have the different greenhouse gases, we do have some different chemical species in our atmosphere, and each of these terms have some radiative forcings. So above we can see for the carbon dioxide, the radiative forcing is positive, approximately 1.5, right? For other gases, other greenhouse gases, for example methane, nitrous oxide, and the halocarbons, the radiative forcing is +1 watt per meter square. Okay, if we are talking about the ozone, if it is the stratospheric ozone, then it will give you the cooling effect. But if it is the tropospheric ozone, that will give you the warming effect. So that's why for the tropospheric, it is a positive side, and for the stratospheric, it is in the negative side. Then the water vapor, as I told you, water vapor is also the potent greenhouse gas, and that will also give you the positive radiative forcing. Albedo has the both effect. uh, whenever there is a black carbon that is forming the aerosol, okay, that will give you the positive radiative forcing, means that is giving you the warming effect. But if the aerosol but some of the aerosol, because of the scattering of the radiation, that can also give you the negative radiative forcing, and that will give you the cooling effect. uh, then yes, we can see for the aerosol, the direct and the indirect, this is giving you the negative, means cooling effect. Then the linear contrails, I don't know about this. Solar irradiance, how much radiation you are getting from the sun, this will also give you the positive radiative forcing. So whenever we are calculating the total human activities radiative forcing, so because of the humans, the radiative forcing in positive means temperature will be increased, there will be warming condition because of the positive radiation. And can you see that the contribution of carbon dioxide is very much equivalent to the total net human activities, so by which we can conclude that most of the contribution has has been given by this carbon dioxide only. Each of other gases have a very minimal contribution because these kind of gases maybe are in very low quantity. Okay, and most of the time we are releasing carbon dioxide into our atmosphere. That's why human activities giving you the major chunk of this carbon dioxide, and that's why the positive radiative forcing. Okay. Then, as I told you, that another indicator was AGGI, that is the annual greenhouse gas index. That can also be calculated from the radiative forcing. For example, as you can see that in 1990, there was radiative forcing that was that was near to the 2.2, right? And then in 2019, that radiative or 2022, that radiative forcing is uh, approximately 3.3 something. Okay, and here there is some different metrics by which like from this radiative forcing you are calculating your annual greenhouse gas index, and you can say that from 1990 to 2022, uh, like if it is a 1.49, means 49%, 49% warming has been done from 1990 to 2022. So this number is related to that. So that's how you can calculate this AGGI. Okay, the next question is, what will be the impact of the global warming? So will it increase in average temperature? It will give you the extreme weather events like heat wave, forest fire, droughts, and all. The increase in sea level, Earth's ecosystem, health, and society. Everyone gave me answer D. Yes, answer should be D. We know that because of that global warming, because of the climate change, most of things are happening. For example, our snow is melting, glaciers are melting. Because of that, there is a the intensity and frequency of the precipitation extreme or the drought events has been increased. Okay, so most of these things will be covered under either climate change, and because global warming is the part of the climate change only. So all of these impacts are associated with the climate change as well as to the global warming. Can you tell me what it is and why I kept this picture? What is the reason? Because we were talking about the impact of the global warming on different ecosystems or the
Coral.
yes, this is coral reef. And what happened to the coral reef? Like in the first scenario, you can see the colorful coral reefs. In the second scenario, there is a whitening. So, can you tell me the phenomena of that?
Decolorization.
Something like that. Like there is a one terminology that we can say. Instead of discoloration, we can use one thing, one terminology. That is the coral bleaching. Okay, this coral bleaching is nothing but because of the increment in the temperature. You know, these coral reefs are so beautiful under the sea, and these are very sensitive to the temperature and even the pH of the ocean water. And whenever there is an increment in very slight increment in the temperature of our ocean, because of that, most of the organism will die. And this coral reef has 1,000 of different type of organisms. Okay, and because of being dying, the color of this beautiful coral reef will be changed into the white. So this is the coral reef bleaching, and this bleaching is just because of the global warming. And like these coral reefs are giving the shelter of many of the varieties of the species in the sea. And whenever there will be no coral reef, the whole oceanic ecosystem or the marine ecosystem will be affected. And these are so beautiful. See, you can go to the Maldives or Andaman Nicobar and you can see the beautiful coral reef there. And right now we are just losing such beautiful species. So this is just because of the global warming. Okay, and even the change, somewhat change in the pH of our uh, pH of our ocean water. Ma'am, ultimately we are not doing anything good. What we are doing is just Just you are taking lecture, we are attending it, and we will get certificate at the end, but nothing for the environment. Glacier will definitely melt. I feel bad. No, you can do like, if you are conscious what is happening in the atmosphere, and maybe sometime you can do the research how this is happening. You can also you can also put forward some ideas how we can how we can stop such kind of explosion, and how we can stop this exploitation. Then maybe you people may go for the civil services, and because you are aware about this environmental things, then of course you can do some policy making. So but the basic thing is you must know about that first. Now either you are going into the research area or you are going to the policy making. If you are aware about such kind of concerns and policies, then you can be the part for the solution. So that's why we are studying. But yes, it is very uh, difficult to formulate some policies to stop it. But yes, we have the potential and we can do it. So anyway, strategies to reverse the global warming will come under adaptation, vulnerability, mitigation, social impact. So I have four terminologies. Whenever you want to reverse the global warming, for example, your temperature is increasing and you want your temperature to go back to that original temperature. So what terminology you will call it? Alka gave me answer C, mitigation. So mostly there is some difference between mitigation and adaptation, and based on that you will get the answer. Alka gave me answer C, that is mitigation. Yes. So answer should be C only, that is mitigation. And you should know the difference between adaptation, vulnerability, mitigation, and the social impact. So we will talk about this first and third. And the second is nothing but prone, how much prone you are to the global warming. So this will come under this vulnerability. But if it is the adaptation and mitigation, so whenever you want to reverse the change, that will be the mitigation. But if you know that temperature will increase, but how can you protect yourself? You can install the AC, you can create infrastructure in such a way that the increment of temperature will not harm you. So that will be the part of the adaptation. So it is important to have both the mitigation and the adaptation, because some of the things that we can't reverse. Okay, uh, we can try even, but sometime it is like it will take at least 20 or 30 years to reverse the changes. Okay, up to then what you will do, you have to adapt yourself. So for example, you are creating the infrastructure, you are having some barrier to protect from the flood, you have the disaster management team or the community. So that will be the part of the adaptation. Mitigation means you are just phasing out the fossil fuel, you are using renewable and energy sources. Okay, then you are using the sustainable transportation, you are growing more trees. So that can reverse your global warming. Okay, but it will obviously will take time. So before that we have to do the adaptation. So but these two terminologies are very important, whether you are trying for the mitigation or the adaptation. Mitigation is the permanent solution, but but before that you have to do some kind of adaptation itself. Okay. Okay, so I have some question about the climate change. So which of the following statement is not true about weather? So there are two terminology. The first is weather and second is climate. So I just want to see whether you know the difference between weather and climate first. So can you tell me which statement is not true about weather? Nishant gave me answer B. It described the average atmospheric condition over long period of time. Pinnacle also gave me answer B. Rashmi also gave me answer B. Yes, if you three people have given me the answer B, then this should be B only. Okay. So the difference in weather and climate is like from that picture you can also see weather will tell you what to wear each day. Okay, so it may be rainy day. Okay, so you must have the raincoat or umbrella. Okay, but climate will tell you what type of clothes you should have in your closet. For example, if we are talking about the climate of India, then you should have the some winter clothes and some summer clothes. But if you will go to the Norway, then your closet must have a very thick winter clothes. So this is something climate. So you will say like the long term statistics of the weather will be known as the climate. Weather is the daily phenomena or the hourly phenomena, but whenever we will have some statistics of the weather, what is the mean value, okay, what is the variability, then based on that we will define the climate. Okay, and whenever there is a change in the long term statistics of the weather, then we will call it as a climate change, right? Okay. For climate change, there are also some natural causes, not only the anthropogenic. So you have to tell me what are the natural cause of the climate change. So I have four terminologies. I think volcano you people already know, but these three terminology may be a little bit difficult for you, but you can guess something out of it. What are the natural cause of the climate change? It is not only the human that is giving you the climate change, but this is also the nature itself that can also lead to the climate change. So there are four terminologies. Rashmi gave me answer A, precession. If you know that if there is a volcano, then this volcano can release a very high concentration of carbon dioxide, a very high concentration of aerosol itself. And because of that, there is a cloud. Because of that, this will restrict the sunlight to enter. The volcano can also give you the methane concentration. So volcano is the one of the option, obviously. Then we have three terminologies as well: precession, obliquity, and eccentricity. These three things can also give you the climate change. So answer will be D, all of the above. These are the three processes. Precession, whenever there will be the change in the direction of your Earth. Okay, and that can also that can take a very long time. That is taking 26,000 years to rotate, to just move the direction of your Earth. Okay, then obliquity, whenever there is a change in the axis. So you people know that your the axis angle can change from 22.1 to 24.5. So whenever there is a change in the axis of your Earth, that can also give you the climate change. Then the eccentricity, when the orbit, because each time orbit can change. Okay, whenever there is a change in the orbit, then that can also give you the climate change, and that is known as the eccentricity. And these three uh, terminology comes under Milankovitch cycle, because Milankovitch was one scientist that told that because of that there will be the change in the climate as well. So these are the natural variability, natural process by which climate can change. But here you can see that time are so long. Show the previous slide where Noah is written. Yes, here is the Noah. Volcano is also the cause of that natural climate change. So all of the above should be the right answer. Why D? Volcano is not included in the cause of, no, volcano is included in the cause of the climate change. I show you, like all of the above, D should be the right answer. Okay, so these are the three processes. Okay, because we are talking about the climate change, as we talked about ozone depletion, and that's why we talked about the Montreal Protocol. So right now for the climate change, for the greenhouse gases, we have 2 or 3 protocols that are very important. The one is Kyoto Protocol, the second is Paris Agreement. So I have few questions for this Kyoto Protocol and Paris Agreement. So you have to tell me what was the primary focus of the Kyoto Protocol. Peter told me that Kyoto primary focus on greenhouse gas. Out of this four option, you have to tell me which answer is the right. Establishing a global carbon trading market to regulate greenhouse. This was not the primary focus. Primary focus was to set legally bind emission reduction target. So each country was given a target, like up to which year, for example, up to 2030, how much of the emission will be reduced. So each country has been given some target to reduce the emission of the greenhouse gases or to stop the fossil fuel. So this was the primary focus, to legally bind emission reduction target for the developed country, because this was the debate that most of the developed country already have emitted a lot. So this Kyoto Protocol was related to, like, it was compulsory for the developed country to reduce the emission. Okay, and if they are not following it, then they have to compensate for it, they have to give the money. So this was the primary focus of the Kyoto Protocol. Okay, when was the Kyoto Protocol signed? Not 2001. Initially, it was mandatory, like for the developed country to reduce the emission, but somehow some of the countries, developed countries, for example, USA, withdrew itself. Like the country told that yes, we can't be legally binded for that. So that's why this Kyoto Protocol was phased out. So it was 1997. The Kyoto Protocol was signed. Then which sustainable development goal urged for the climate action? So you people know that we have some sustainable development goal, SDG, and you have to tell me which goal urges for the climate action. Nishan gave me 13th, means C. Okay, so answer is C. We do have like this sustainable development goal has been adopted in 2015, and we have the 17 goals. Okay, so like first is no poverty, then zero hunger, good health, and good and wealth being. But the 13th goal is related to the climate action. Okay, so out of this 17 goal, the 13th goal is related to the climate. And the tagline was climate action. So in that 13th goal, that was to take urgent action to combat climate change and its impact. So there was three sub goal, 13.1, 13.2, and 13.3. So 13.3 was related to the strengthen resilience and the adaptive capacity to climate related hazards and natural disaster in all countries. 13.2 was related to integrate climate change measure into national policies, strategies, and planning. And 13.3 was to improve the education, awareness rising, and human and institutional capacity on the climate change mitigation, adaptation, impact reduction, uh, and the early warning. So the goal 13 was based on the climate action. Okay, so we talked about the Kyoto Protocol. Now we have the another agreement, that is the Paris Agreement. So you have to tell me what is the primary goal of the Paris Agreement. Nishad gave me A. Rashmi also gave me A. Alka also gave me answer A. Yes, answer is A. The primary goal of the Paris Agreement was to limit global temperature rise well below 2 degrees Celsius above pre-industrial level, and we do not want to exceed it to the 1.5 degrees Celsius, and this was the primary goal of the Paris Agreement. Here we can see like we had three goals. The first is to limit the average global temperature increase to less than 2 degrees centigrade and plus achieve net zero emission by mid-century. This was the main primary goal. For that, we have to enhance our resilience and the adaptation to climate impact. And then we have to align financial flows in the world with these objectives. So we must have some funding so that we can adopt some changes. So this was happened in Paris Climate Agreement. Okay, so when the Paris Agreement was signed, in which conference of parties? Can you guess? Rashmi gave me answer A in 2014. Not 2014, but little bit near to it. Alka gave me B, Rashmi C. Not it. The answer should be B. So this agreement was signed on December 12 in 2025, and this was when like COP21 was held. Do you know about this conference of parties? And every year there is a conference of parties, and right now we are on this 27th or 28th. So you must know about something about the conference of parties, because this such kind of convention happens just to regulate the greenhouse gas emission. Then which of the following statement best describe the significance of the Paris Agreement? I told you that in this Kyoto Protocol, it was legally binding for the developed country to reduce the greenhouse gases, right? But because it was not good, developed country didn't follow. So that's why Paris Agreement came into force. And so what was the significance of this Paris Agreement? Paris Agreement was not for just for the developed country. It was for all the countries. And this Paris Agreement gave the direction that all the countries must have some targets of the emission reduction. So India also have some emission reduction target. So India also said that by 2030 it have to reduce some percentage of its emission. So how much it is, you should know about this. So this was the significance of Paris Agreement. Can you tell me the answer now? What should be the answer? As I talked something about Paris Agreement now. Alka, note, I told you that Kyoto Protocol was legally binding, but this Paris Agreement is not legally binding. So the answer should be B. It provides a framework for all countries to set their own national target for reducing greenhouse gas emission. Could you send this note to us in course transcript? Yes, I can send, obviously. Okay, so there is a one terminology in this Paris Agreement, and this is nationally determined contribution. So what do you mean by this? Yes, okay. So time has been up. I think I have one or two question more. So yes, Rashmi, you can leave. Otherwise, we will solve this two question and we'll leave. So can you tell me what do you mean by this NDC and what should be the right answer? Nationally determined contribution. So how much this is the reduction target of each country. So Answer should be B. So these are the voluntary pledges made by country to reduce their greenhouse gas emission and enhance their climate resilience. Uh, this is not that much important now. Okay, so there are some differences between Kyoto Protocol and Paris Agreement. The first is it was created in 1997, but Paris Agreement was signed in 2016. Then the first was legally binding, and Paris Agreement was not legally binding. And then this first was for the developed country, then Paris Agreement for the all of this country. So you should know some differences between the Kyoto Protocol and the Paris Agreement. Uh, okay, this is the last question, I think. What is the pH of the acid rain? Can you tell me the pH of acid rain?
A.
Yes, answer should be A. That is less than 5.6, because even for a normal rain, the pH can be 5.6. So whenever there is a less than 5.6, then we will call it as a acid rain. So I think I will not cover. I think this is. Time has been up, so I don't think that I will share this slide with you. You can see the answer, because there are only 2 or 3 questions that are left. So anyway, you people can go. To 4.2 to 4.4 pH range for acid rain. Yes, most of the time pH range is like in that 4.4 to 5 range. But yes, whenever there is a less than 5.6, then we will consider it as the acid rain. And whatever you told me, that is the normal average range of the acid rain. So thank you so much for being very patiently listening, and I hope that you will come again on Monday from 6 to 8. Thank you so much. If you
Thank
have
you,
any
ma'am.
query, you can ask. Thank you, Nishant. Otherwise, you can leave if you don't have any query. Should I leave?
Ma'am, for the exam, if you study this PPT is enough, ma'am.
I think this should be enough, because whenever I create MCQs, most of the time I have the like every time I have the content that has been covered by sir. So most of the time my question is related to or near to that only. So, and I always try to cover all the topics that has been covered by sir. So I think that should be enough. But yes, you can read the material that has been provided by sir. That would be enough.
Okay, ma'am.
Yeah, Nisha. Please send the reference